Hi, my name is Lily Jasmine Notice, and in this video we will be going over chemical kinetics. In your ACS book, it is chapter 10, page 124, study question number 1. So the question that we have before us is, what is the rate law of this reaction? Here we have our equation, and here is our data table. So first and foremost, we are going to write our rate law, remembering that our rate law only includes reactants, not products. And if you recall, the K is defined as the rate constant. So I'm going to put the exponents in a different color because this is what we are solving for. And so to determine the X in the hydrogen gas, we're going to look at our table and we're going to define and isolate the hydrogen gas by finding one concentration that is constant for the nitric oxide, which is trio 1 and trio 3. And we're going to be looking at the initial rate and all of the concentrations. And so to set up the equation, the initial rate, which has the higher number, will be in your numerator. So that will be trio 3 and trio 1, and trio 3 will be on top. So I'm just writing this rate law over again, and then we will plug in these numbers. So now we will begin to cancel out our common constant, which will be our K's, and concentration of our nitric oxide gas. So now we're going to use our calculator to solve for this. Our exponents. So this side also equals 2. When we bring down our exponent, we want to ensure that our right side equals our left side. So in order for this 2 to equal this 2, this exponent needs to be 1. So our exponent equals 1. So now we will determine the rate law for the nitric oxide gas. So we're going to rewrite our equation. This time around we will be using trio 2 and 3. In this column, the hydrogen gas is constant, in which we will be able to cancel out these terms in order to find the nitric oxide gas. And we are going to be putting trio number 2 in our numerator because it has a higher initial rate. And now we're going to plug in these numbers. Now we will cancel our like numbers, VRK, and our hydrogen gas concentrations. So now we will use our calculator to determine the change. Equals 2. So we're going to bring down our exponents. So now we have to ask the question, how can we get our right side to equal our left side? And if you think about our exponent, we know that x needs to be 2 for it to equal 4, because 2 to the second power equals 4. We can now write our final rate law equation. So our rate law is going to equal K constant, our hydrogen gas to the first power, and our nitric oxide gas to the second power. And oftentimes this one is not written, because unless stated otherwise, the concentration of a reaction order is always 1. So now we're going to look back in our table. We can get rid of this. And we can determine that our answer is B. Again, my name is Lily Jasmine Notice, and we just went over study question number 1. I hope you guys enjoyed the video, and I hope you understood it. Bye.